as a single logarithm. Okay, so if you have log base 3 of 4 plus log base 3 of x plus 1. Okay, so sometimes you don't have coefficients to worry about. Here you don't have, oh, let me make that 3 look more like a 3. Sometimes it just goes right into it where the only thing you have to worry about is 1 plus sign or 1 minus sign. Okay, so here, log base 3 of 4 plus log base 3 of x plus 1. We have that plus sign. So that's the product rule. Okay, so that means we have log base 3. Since as long as our bases match, we can combine them. You have 4 times x plus 1. And I'll use the bracket to kind of separate those. So this, right after you distribute that, becomes log base 3 of 4x plus 4. So sometimes they're really quick. All right, any questions on that one? All right. Looks like everyone's done. Okay, so let's say, for example, if we wanted to write as a single expression, sorry, I'm back. I'm not trying to get electrocuted today. So at least that'll stop it a little. At least from getting in the machine. Okay, so write as a single logarithm. So what if we have log of base 9? Make that look more like a 9. Of 5 plus log base 9 of w times x minus log base 9 of z times y. Okay, so just like the last one, we don't have any coefficients to worry about. This is just straight add and subtract. So log base 9 of 5 plus log base 9 of w times x minus log base 9 of z times y. And remember, going left to right, you have a plus sign, so you know you're going to have your product rule. Okay, so these two terms become log base 9. Oh, there we go. Make that 9 look more like a 9. Of 5 times w times x. And we still have our minus log base 9 of z times y. Okay, so now we get rid of our minus sign. So minus sign means quotient rule. Okay, so these two terms will combine to give us log base 9 of 5wx divided by z times y, or y times z, which is your one log term. All right, so any questions on that one? Okay. All right, for our next example, okay, so express as a single logarithm we have log of 4 plus the log of 25. Okay, let me rewrite that. So you have log of 4 plus the log of 25. Okay, since we have a plus sign here, we know that's the product rule. So that's going to be log of 4 times 25, which is the log of 100. Okay. Now, if you remember, whenever there's no base, you automatically assume the base is 100. Not 100, it's 10. Okay, so no base. So assume that b equals 10. Okay, so that means this, you can rewrite it as log base 10 of 100, which can be simplified. Rewrite this as log base 10 of 100 equals y. We have 10 to the power of y equals 100. Bring that up a little bit. Okay. Now we know 100 is just 10 squared. So that's 10 to the power of y equals 10 squared. Our bases are the same, so that means our exponents have to be equal. So we have y equals 2. Okay. So that means log base 4 plus, bring that up a little bit, plus log of 25 is equal to 2. All right. So any questions on that one? Okay. Oops, seems like it stopped. Nope, guess not. Still writing. Nope, looks like everyone's done. Okay, so now we're going to look at the change of base formula. Okay, so the change of base formula came around because most calculators, before you get into like the really deep graphing or scientific, they only had a base of 2 and a base of 10. Everything else was kind of off limits. Okay, so you have the log base b of x can only be solved in pretty basic calculators for base equals 2 or base equals 10. Like I said, once you get into the graphing calculators and everything else, it's different. You can set it to solve these, but for those really basic ones, you can't. Nope, actually it's one more. You have base e. So base 2, base 10, or base e. You add that to there. B equals 10, or your base is equal to e. And remember that e, that's just your natural log, equals log base e. Okay, so with the change of base formula, if you have the log base b of m, that's going to equal log, and you can change the base to any positive whole number of m divided by log base a of b. Okay, so once you change your base, you just get your m value here, and then your former base, I guess you can call it that, in your denominator. A is any positive, I guess you could say integer, but it's more like, well, not even integer. It doesn't even have to be that. Any positive number. It can be anything except 1. Okay, so for example, let me actually mark that as the change of base formula. Okay, so let's say, for example, if you want to find log base 3 of 5. Not even find it, just express it as change of base. Okay, so if we want to find log base 3 of 5, using the change of base formula, in this case your base is equal to 3 and your m is equal to 5. You don't have to write that out, but it's just kind of showing it. Okay. So that means your log base 3 of 5 is equal to log, we can use any base we want. So let's say log base e, in this case 5, over log base e of 3. And the reason I picked e is because the most popular change of base is to just make it natural log over natural log of 3. Now, if you wanted to, you could have made that log base 10 of 5 over log base 10 of 3, and you get the exact same answer. You can make it log base 12 of 5 and log base 12 of 3, you'd get the exact same answer. So no matter what you make the base, as long as they match, you'll get the same answer. Okay, so using natural log for change of base, is the most popular. Oh, bring that up a little bit. Okay, so any questions on that one? Okay. All right, so let's do a quick example. Still writing. Nope, looks like everyone's done. Okay, so what if we wanted to write log base 4 of 10 as a quotient of natural logs? Okay, so this one's pretty much telling you we want you to use natural log as your change of base. Okay, so again, you have log base b of m equals, in this case, it will be natural log of m over natural log of b. Okay, and that's your change of base. If we use natural log. Okay, so that means that our log of base 4 of 10 is going to equal the natural log of 10 over the natural log of 4. Okay, so it's pretty straightforward. Okay, so what if we had the example, move that up a little bit. Use the, and this problem coming up you won't have on the exam because it requires a calculator, but you will have some on the homework. So use the change of base formula to approximate log base 6 of 51 and round it to 3 decimal places. Move that up a little bit. Okay, so we know just using the change of base formula that we used up here, that log base 6 of 51 equals the natural log of 51 over the natural log of 6. Okay, so if you plug that into your calculator, you would actually get 2.194. Okay. Now on your homework, if they ask for it, this is what you'd use, but on the exam, this would be your answer here. Okay, this is your homework answer. All right, so any questions on that one? Okay. Let's see if they have that one. Okay, so let's say if we have, oh, anyone's still writing. All right. Use the change of base. Formula to approximate log base 9 of negative 60. Okay. So this one you don't have to do a thing. Because remember, that always has to be positive. So the minute they throw a negative number in there, it's undefined. So log base 9 of negative 60. In this case, m is less than 0. So the natural log is undefined. Okay? Those are those little rules that kind of sneak up every once in a while. So just undefined would be your answer. Okay. So any questions on that one? All right, so we're going to stop there so I can tell them about this leaking roof.